Good. Does everybody see the screen?
See you.
You
And the
see
screen,
me, eh?
yep.
You see the screen now? Good.
Yeah, you need to queue up your PowerPoint for
Yeah.
slide view, but it's coming through
Okay.
fine.
Good. So, yeah, I'm up in the Yukon. Been keeping bees here for about 8 years. I've kept bees in northwestern Ontario, so north of Minnesota, uh, for about 3 years. This presentation is a hybrid presentation. I'll cover some of my wintering approach, but also I'll go through some of my, my monitoring projects that I've been doing over the last 2 years to get an idea of basically what goes on in a hive in a cold climate or a very cold climate. Uh, you'll see that, so I use polystyrene hives, a mix of different kinds. And then I use medium boxes to build really high insulation covers and tops. But I'm skipping over, so I'll just follow my presentation. So Yukon, I guess it's decent sized territory. There's only 40,000 people, so there's actually more moose than people up here. It's a subarctic climate. It's fairly dry. Not many beekeepers. I've marked where some of the northern beekeepers are located. There's probably 150 hives up here in the Yukon. We produce maybe 4,000 pounds of honey. We don't have any regulation, so we're all self-regulated, and so it's good and bad. So my bees were very forage limited in the north, in boreal forest settings. So usually you can't have more than 2 to 4 hives in one location. So I've got 3 yards spread out, probably 5 kilometers away, and then another one about 15 kilometers away. And I get queens from southern BC, from California, or I raise my own queens up here. And there's actually no difference in performance. Other than one bad winter, I'm usually in the 90 to 100% range of winter survival. I had a run-in with Nosema a few years back that introduced me to the whole Nosema thing. So I'm an engineer by background, so I'm data-driven. So first thing I wanted to do was to review, I guess, the BIP numbers for northern states. And in the next slide, I've got some numbers for Kappa, so the Canadian version of this. And just to see where we're at as a group, backyard beekeepers, sideliners, and some commercial, and to see what works and what doesn't work. So BIP is actually pretty good. You'll see a lot of the slides are heavy. They're designed more for you for afterwards, so you'll have access to the PDF, and it's more for reflection. But you can see how there's some key concepts. Based on the stats, there is no age, or there's no wisdom with age. So based on the age of the experience of the beekeeper, doing something is better than nothing. Treating for mites is better than not treating for mites. Feeding pollen is better, and then feeding syrup is better. But you'll see there's a floor. About a third of the hives in the US, in the northern states, don't make it through the winter. And you can see no matter what we do, we hit that floor. Even if we feed protein patties or feed, we still can't get better than that. So for Kappa, different format. You can see that outdoor wintering has a better success rate than indoor wintering. So about a quarter of the hives in Canada are wintered indoors. Mix of reasons, so starvation, wet bees, mites, clusters, weather. I put the chart from last year. And one thing when I do my beekeeping course or I coach people is the sooner a beekeeper learns to own the reasons, either via lack of knowledge, lack a consistent approach, just not really understanding how to prepare their hives for their own locations, don't manage their pests or diseases, and then they try to overwinter weak hives or smaller hives, really large volumes. So you'll see as I go along with my monitoring, I've successfully overwintered a 5-frame nook up here. I do singles, I do doubles. So I've noticed that it has nothing to do with, I guess, it's the strength versus the volume of that hive that's important. And it does have to be insulated up here, but the 5-frame nook did wonderfully. And I've got a couple more this year running through the same type. So we all know beekeeping is local. So whatever I do, you need to learn to adapt it to your own location or understand the concepts and the tricks. So it's clear that with the monitoring, so I've got a double with 24 sensors in it, and then I've got a single with 14 sensors. And it's clear we've had minus 35 already this winter. And it's clear that for example, at the bottom entrance, the coldest temperature I've had there, I think, was minus 9 Celsius when it was minus 35 out. So, but I'll go through that as I go. So, and I've done the heat loss calculations and stuff, and it's pretty obvious that the waste heat coming off the cluster is enough to keep that environment at a decent temperature in an insulated hive. I don't use any top entrances because I just find it's a waste of heat. And then it defeats the purpose of natural convection currents. So challenges, I'll go fairly quick through this, and you'll see some of the slides I'll just skip over, or I'll highlight a key point, but it's more for yourselves to review. So we do get, I think last winter, the coldest was minus 50. We had about 3 weeks of minus 30 to minus 45. But typically it's around a minus 15 average over the winter. Our last pollen is usually early August. Winter bees are being raised basically from the end of July to mid-August, and usually the queen slows down by early September if she hasn't stopped laying already. There's no cleansing flights from October to April. In my case, I guess Nosema serrane seems to be the biggest issue I have. They'll usually overwinter well, and I'll have 14 frames of bees coming out of winter. But then I'll get a crash in May and June where the aging process, once they start foraging again, returns to normal, then the mortality rate just goes exponential and they can't make up for their losses, and then I get a hive collapse. I do my own microscopy, so I test my own bees. I also send samples out to the lab just to make sure on the type. So we get cold, but not very much snow. So this year's an exception. So we've gotten a lot of snow, but usually we don't. And very few experienced beekeepers who are successful. I'll just run, I won't even run through this, but this is when I coach people. I've got one for overwintered colonies, and then I've got one for packages and installing nooks. And it's just the basic management approach that we use up here as a baseline. I use screen bottom boards, and I have them wide open in the winter, but they open into a dead airspace. I'll cover that in a bit. But I do, most of my inspections are like 5-minute inspections. It's look at a couple of frames, look for some brood, the location of the brood. Because I use polystyrene hives, they tend to build the brood right to the last frames on either side. I do 9 frames in a 10-frame box. In the winter, I typically insert a pine board to fill that gap, and it just helps with and actually leave it year round. It gives the bees a location to propolize because they don't like poly, and it's a concept called sorption. So it allows the wood to absorb some of the moisture and then release it if the bees need it, if it warms up. So bottom boards are part of all my inspections, and I show people how you can see where the bees are hatching, fresh wax, chalk brood, when you do your mite tests, I guess, to check your efficiencies on your treatments and natural drops. There's a bunch of stuff you can do with your inserts. We get 2 nectar flows. So there's one late June to July, early July, and that one's about 25 to 50 pounds per hive. And that's all the Yukon native flowers. And then in the midsummer, July, this one is hit and miss, and that's the fireweed. And mixed into the midsummer one, we get a honeydew flow. So if you remember that first picture, I'm not sure if you saw it there, but I'm in a mix pine spruce with some aspen type forest. Like I said, I'm very data driven. So people didn't have any records of what bees forage up here. So over about 3 seasons, walking my dog, taking lots of pictures, looking where the bees growing, buying a $20 pollen collector on Amazon, and doing 6 hours of collecting per 2 weeks gave me a pretty good idea of what's going on. And yeah, so there's some really interesting flowers that the bees forage on up here, which comes to, like I mentioned, our last pollen is sometimes the end of July. So depending on the location, we have a lot of microclimates because of the mountains. And once the pollen drops and towards the end of the season, so early August, it's very single source. So it's pretty much just fireweed. And then the first week of August, maybe second, we get a killing frost and it kills everything. So closer to town, they do get sweet clover. So they do have access to that. But in my location, I have very little non-native plants. So over the last 8 years, basically for me, I know there's studies that say pollen patties don't do anything in the fall, but I used to overwinter with 4 to 8 frames in a box. And now when my boxes are coming out of winter, there's 16 to 14 to 12 frames of bees. And the big difference is I never fed patties before, and now I start feeding late July, early August for a couple of weeks, just to make sure they get that last round of brood rearing. So I'll skip over this, but it's important to assess your queen as early as possible to make sure she's top notch, especially with her short season. So this is how I do it. So winter health risk up here. So it's nosema. It's trying to winter a really small cluster in a really big hive. The other one is rust spores, because the flowers die off really early. You've got the wild rose and the fireweed, and even the spruces and all those plants. There's rust powder on them, and the bees start collecting them, and they start packing the hive with that. And I guess I can't see because of the screen here. There we go. And you can see how these are 2 different locations. How my home location, it's green, so it's all fireweed. And then another location, there's some yellows and a bit of orange. So the yellows are actually brassicas from people letting their gardens and their fields go to seed. And this is just an example of the rust spores. I discovered some things, and then I ask questions, and then I discover what they are. So we're going to get into winter now. So one challenge is every region. So I'm looking at the black box right now, the box with the black rim or border, is every area seems to have their own way of wintering. And when I first started, I was getting advice from down south, and I was like, ooh, and it just wasn't applicable. So I was looking for a measure I could use to compare, I guess, the intensity of the winter. So I created something called cluster degree days or cluster degree hours. And it's like heating degree days or the opposite of growing degree days, but using hourly data. And I use 8 degrees Celsius as my cutoff because the bees tend to be, they start foraging at about 8 degrees Celsius here. So you can see how from the north, so Dawson City and Mount Lorne, so the third one over is my location. So there's Fairbanks, the second, and then you go down and you could see how it actually gives me a measure of the intensity of those winters. And you can see how I also created 2 other measures. So something called forage degree hours, so temperatures above 8 degrees Celsius, and then nectar degree hours, and that's temperatures over 16 Celsius. And if you ever want a spreadsheet on how to do this and where to grab your weather data, it's a nice, neat tool to compare climates in different locations. So this is just how I calculate the things and how to read the charts. So when you do get the PDF, if you have any questions, just let me know. And this is just an example of a place in Frederick, Maryland. So I'll be doing a talk to the group there. So I just wanted to show what the difference is. And you can see the scale here, 1200 degree hours. So up here, it means pretty much around 1200 it was minus 40 the whole day equivalent. And the green bars is forage hours. And you can see how the magnitude difference is. It's quite huge, but we're still able to grow our vegetables in our garden. The flowers are there, and I guess the habitat's there. And our short, intense summer, I guess the plants probably produce a lot more sugars per unit assumption. So being an engineer, I like flow charts and processes. And I've read a lot of papers. So what I did over, I guess I wanted something, I'm just moving this. So basically, when I'm coaching people and other fairly technical people, there was 3 levers. There was health, absolutely. You can insulate your hive all you want, but if your bees aren't healthy, they won't make it through the winter because nutritional stressors, nosema, too many mites, small clusters. And you can see how I just put connections. So nosema, I find that if I do get a high mortality and it's clear that that hive has nosema midwinter, honey consumption is a lot more than a healthy hive. And that's just due to the gut not being able to process the food properly. Let's see, I'm gonna move this again. No, I've got the picture bar. There we go, it's out of the way now. This end part here, there's 3 factors in the actual hive enclosure. You've got the insulation value, you've got the volume versus cluster size, and then you've got ventilation. So passive is no flow through, only using natural convection. Active is where you'd have probably a top entrance and those top type venting situations, top covers and stuff like that. One key point about food, my hives, a double here might consume 40 to 50 pounds under my setup. and I know it's equivalent to what a lot of people do down there. And you can see how, I'll show you a chart a bit later, but the consumption per week is a lot lower. So technically, it's actually a lot less moisture being generated. And you can see how I put a bunch of stuff there. So I could probably do a 1 hour talk just on this one slide. But I just wanted to show to you that I keep adding to it if I discover new things. And you'll notice here I put honeydew. So that year where I lost all my hives was the first year I got honeydew. But also it was the year we went on a trip, and I didn't get back here till mid-September. So I couldn't actually do my prep properly. I tried feeding late, even though the hives were really heavy with honey. It was honeydew. But I also trialed some top entrances that year. So those were the two factors that were different from my other years. So winter's success, we all know. So lots of healthy bees. When's your last pollen? That's usually the first question I ask. When's your first pollen? When's your last pollen? Adequate stores. I aim for about 60 per brood box. If I do a single, I want at least 60. If I do a double, I want at least 120 pounds all in. And even though they only consume a fraction of that, it's the thermal mass is critical, especially in a really cold climate. And that waste heat coming off of that cluster, if there's a lot of extra honey, especially in late winter, early spring, it absorbs and holds it and then releases it on those really cool or cold nights. And it helps really level out those temperatures. Over here, dry home to spend the winter. So I tape all my seams now with that red tuck tape. And even though they're poly, I found most of my condensation occurs at those seams. And top insulation is critical, and then side walls. And people need to understand the difference between moisture and condensation. So this is my system for monitoring my my nosema. And because bees, when it's cold, they just die at the entrance and they don't really fly off. So I actually do a subjective, I guess, evaluation of how many dead bees in front of the hive in a 2-week period. And then it gives me a feel of, and then I test 10 to 25 of these dead bees. And then I can see what's in their guts, their nosema level, did they even die of nosema, old age, and different things. So, and now it's, if I see high mortality and really high spore counts or relative spore counts, because I follow the same procedure, then it's pretty guaranteed that that hive will probably make it through the winter, but I'll be dead by June once foraging starts over. So here, June is actually quite cool and wet. So when I do my splits, I tend to do them in July or late June. So it doesn't give me much time to get those colonies to size for winter. And I guess most of the advice out there is always about combining weak hives. But is it weak because of a weak or malperforming queen, or is it weak because you didn't have enough time to grow that colony? So now, because I've trialed all the different sizes and they've all been successful, if the bees look healthy and the queen has really nice laying patterns, but she won't be able to fill a double, then I might put the colony in a single. And if it's a mid-July split, or I've got some queens that I need to take care of, then I'll throw them in a 5. It's a 6 frame, but I put 5 frames in a nook with a lot of top insulation, and they do fine. Metabolic rate. So right now I'm working on some calcs to try to figure out how to measure this using temperatures and heat loss. But in general, this is the one I want to look at because in my insulated hives, there's not much heat loss. So even when the temperature goes up to 35 degrees Celsius for brood rearing, there's actually not much difference other than feeding the bees, because the heat loss it does increase a bit, but it's about 6 times less energy required to keep that hive at the same temperature. And if we have time there at the end, I'll show you what the impact of tapping, disturbing a hive. So a couple of weeks ago, I had to change a battery in one of my sensors. So I tilted it off the bottom board. So it was a sensor on my slatted rack. Just on the edge, I popped it open for about not even 5 minutes and brought it back down, and you'll see what the impact on the cluster is. So where does water come from? It comes from, I guess, the consumption of the honey. So they metabolize the honey, but they actually produce more moisture than is actually in the honey. So we think, oh, there's only 18% water in that honey. But to the chemical reaction of breaking down those sugars actually generates about 1/3 of a cup of excess moisture that the bees would have to deal with. So when I asked the folks in Maryland how much honey they consume, they said about 50 pounds. So my double does about 50 pounds. So over 210 days of no cleansing. So you can see how, I guess, my bees up here, they have to be more efficient or else they wouldn't make the winter. So controls, the moisture can be kept in vapor. If you maintain a decent temperature inside the hive, you can allow it to vent out via top entrance. And I guess you can vent it out through the bottom entrance via convection, or you can just let it condense along the side walls
Etienne,
on
5 minutes,
purpose.
please.
Okay, I'll have to go really quick. So yeah, time flies, but you can see how I do have an IR camera. The challenge with these poly hives is these plastic edges, they're actually heat sinks. So when you actually do look in the hive, you can actually see where the condensation happens. It happens where those sensors were and where I guess the plastic is. So now I chop this plastic tab off all the sensors, and they're only a couple inches long now, so they don't hang through the back of the hive. So I'll skip through. So this is my basic setup. To get a lot of extra top insulation, you can see how I put 4 to, sometimes I use a deep box, and I just put extra insulation in it. Those are those pine boards I was talking about along the edges. I'll plane them down to 1/4 inch now and really rough them up so that the bees can actually prolyze them properly. So this is a typical single wood hive setup up here where he does use a top entrance, but he has a very small bottom entrance on a solid board. And this fellow here, it's been 6 years now, and he winters 3 to 5 hives, and he hasn't lost one yet. So it does work. And in the burlap, it's just wood chips. This is a 4-pack up here that some folks do with 4-inch styrofoam and with a quilt on top. And usually winter here, we like feeding pollen patties the first warm spell of March to get the brood rearing going. So we need a way to feed them without unpacking the hives. So we just pop the top and we're able to throw a pollen patty in that middle slot there. I'll skip that. So, and I'll just go to the extra content. So let's see. So over here. So this was me opening up the hive on November 8th. And you can see how all the temperature sensors spiked up. So these, I've got 9 sensors on this plane, and then I've got sensors on the bottom plane here, and I'm just using a nonlinear quadratic type equation that I got from somebody to help me sort of estimate what the temperatures would be between these. If I had to do it again, yes, I would add secondary sensors to fill some of these gaps, but it gives me a decent approximation of what the cluster looks like. And using the areas of the temperature gradients, isotherms, I'm able to estimate what the radius, I'm actually using a hemisphere as my shape, because a really well insulated hive, the side walls, actually the thermal conductivity is a lot less than what the cluster can do naturally. So the bees actually use the sidewalls as part of their cluster. And even at minus 30, I've got a couple of slides at minus 30, and you can see that they're using the side. And the double is actually using the sidewall as part of the cluster side, the upper side. And you can see how I just estimated the number of bees at the different isotherms. And now this is 3 hours after, 1 hour before, and 3 hours after I cracked that hive open. And you can see all the bees, everything just went crazy. It actually took about 2 days for the hive to get back to normal. And this is about normal. And you can see the energy. So if I use Southwick's chart to chart using the average temperatures below the cluster as what the cluster is exposed to, that's how I calculate this. So it's an average of 9 degrees Celsius, and this is what it comes out to. And then the equivalent honey for that energy is over here for 20,000 bees versus 30,000 bees, because that's the estimate number of bees in that box. So I'll just go to the minus 32. And you can see that even at minus 32, the temperature just above the slatted rack is minus 3, and below it is minus 9. And just a couple of days ago, I found a really interesting relationship between the outside temperature and this bottom board temperature. And it's a nice linear line. As the temperature gets cooler or gets warmer, it has a really nice slope. So it's likely connected to convection or natural convection, and it should let me do some calculations there. But yeah, in a nutshell, that's what I wanted to present.
So we have some
and then over here, if I've got, okay, so we'll just go to questions then.
Okay, so I let everybody know you've got some pretty dense slides that deserve some pondering and inspection. So we are recording these presentations, and following this meeting, it'll take us a few days to get this set up, but we're going to set up a YouTube channel, and everyone can go to those and go through the presentation, stop it, and look at the slides and so on. So the other issue is that I'm sure Etienne would be glad to answer questions to you by email or after the meeting here. So let's start with some questions. So one of the questions here is that now that Fumidil is back on the market, are you thinking of or contemplating using Fumidil?
So I have a small bottle, and from some studies, because a lot of the studies were all on Nosema apis, but I'll probably do a trial where I'll do, so right now I did my sampling for October, and I've got some samples that I have to crush for November. And the hives that show, if I do get high mortality and lots of Nosema, then first feed of, pretty much I'll do a baggy feed of Fumidil in March or April on a sick hive, just to see if it makes a difference.
Okay. Another question is, do you have a preferred pollen supplement recipe?
I use Global Patties, so either the 55% pollen or the 15%, depending on availability.
Okay. You mentioned rust on pollen. Is that much of a problem? And if so, what kind of plants is it coming from?
So it's coming from the expired fireweed and from the roses, and probably the willows, and probably the aspen, and probably the spruce. Because once the frost starts happening, you can actually spot it on all the plants. It's like an orange rust. And I thought I was like, what is that red? Because it actually, almost like my cursor, it was like a red pollen ball like that. And I was like, what is it? And then I had a fungi specialist identify the spores for me.
Okay. There's a request from Steve Sweet asking if you could provide a link on the weather data that you have.
Yep.
Okay. So, and this question resonated with me because I've looked at honeydew collection in Europe and also down in New Zealand. I know that the New Zealanders really say that the hives take a beating when they put them on honeydew. They have to supplement feed them, and they can't go into any type of dearth right after it, or they have a real problem. But the question here is, someone's asking whether you consider honeydew to be an inadequate food supply.
I've had it probably 2.5 years. So 1 year, I guess. So 2017, 2018, and 2016, probably half was honeydew. I guess the saving grace is we tend to get an early frost in August. Everything dies, and then I have to supplement feed anyways. And I'm pulling my honey supers. And the way I do it is I try to make sure that my bottom boxes are chock full of I guess, sugar syrup, honey before the honey flow. I try to time it so that it never gets backfilled with honeydew. And then as the nest gets hatched out, that's when I start trickle feeding sugar syrup. And then I go bulk by the end of August. I'm doing gallons or 2 gallons at a time. And I put maybe 25 pounds of sugar equivalent syrup in it.
Okay, I'm going to give you
now that I know about it, yeah, go ahead.
I'm going to shift the question. There's been the questions about whether you build or buy your own polystyrene hives, and if you purchase them, which ones do you like? And the associated question is, do you see the bees chewing on the polystyrene?
Let's see. I started off with the Paradise boxes there, those boxes from Finland. I like how they fit each other. It's a nice snug fit. The only problem is you can't feed pollen patties and feed syrup at the same time. So I've had to make shims. The problem with shims is now you're adding a heat sink that actually pulls heat out. It causes condensation at the top. So that's the flaw with the Paradise hives. And I'd say the ants were worse at chewing the hives than the bees. We got carpenter bee or ants, and now I use that Tanglefoot that Jerry recommended a while back, and it works really well. I've trialed the license beehives. They're thicker. They run a lot more humid because I plug all the top entrances on them, but they actually overwintered really well. And there's plenty of space to put a pollen patty, and they've got big bulk feeders on them. So they all have pros and cons. And like my slated rack, I made that myself. And then I just insulated it with 1 or 2 inch styrofoam. Just because nobody makes those insulated or out of polys. And I don't have issues with birds or anything, pecking or woodpeckers and stuff like that, squirrels.
So two more last questions here. Have you tried sticking a low wattage light bulb underneath your hives? And if so, did that do any good?
you can see by the temperatures, I don't even have to. By my estimate, just the waste heat off that cluster is about anywhere from 8 to 10 watts. At minus 30, it might go up to 10 watts, but the bees seem to like that range. And if you look at the Southwick chart, which I'll provide, that's the optimal. So it's the 5 to 10 degrees Celsius most efficient wintering temperature and what they try to do indoors. So nope, I haven't had to do that, and I don't have power at my beehives.
So the last question I've got here is, how much honeydew do you harvest honeydew honey? Is it extractable? Is it tasty?
So I was doing some honey microscopy today, but my 2017 one is a type of honeydew that even the Slovaks and the Polish beekeepers at Apimondia had no clue what it was. It's weird. And I've never had a honey like that, really viscous. When I extracted it, because the frames are so fat, so I did still get about 50 pounds out of one medium. But now I have a guest cabin. I stoke the fire up, and it's like 35 degrees in there when I do my extracting, and I get my frames dry now. So I'd say, and 2018 was spruce, and I'd say spruce honeydew tastes great, and it was really nice. So right now I'm actually trying to learn about aphid life cycle and figure out what the optimal temperature and triggers are for honeydew, because it's probably I had my honey tested using the nuclear magnetic resonance test, so it gives you all the different acids and sugars. And so there's some interesting acids in the section where they talk about manukas. So the honeydews have like skikimic acids, and there's all these types of acids that and amino acids that are really interesting and really interesting medicinal properties. So things that I'll be looking into.
Great. Well, we're running out of time. I assume you're staying around for the members meeting, and I suspect afterwards you might entertain a few more questions if people want to stick around that late. But I do want to say that we got a comment here that says and I agree with this, great presentation. A great bunch of information. It's a real credit to the organization. Well done. So, sir, thank you for your time today and your presentation, and we'll be sure to post all your information and your presentations online for everybody, both who are online now and for those who aren't but who registered, so they'll get to them. So thank you for your time. How cold is it up there in the Yukon territory tonight?
So it's just minus 11 right now.
That's centigrade.
Yeah.